Hello guys, so in this video we're going to be determining the change of enthalpy, but rather than using limiting reagents and stuff like that before, we're going to use Hess's law. So we are given a total of four reactions here, the main one being AgFG that gives us HF. And we have these three equations that we have to manipulate in different ways so that we can add them together and get our change in enthalpy. So let's do that. For the first one, we don't need to change anything, so we can just have it as H2G plus Cl2G that gives us 2HCl. And the enthalpy is negative 184.6 kilojoule. The second one, what we're going to do is we're going to flip it over. So rather than F2Cl2 giving us 2FCl, we're going to have 2FCl giving us F2 and Cl2. So just like algebra, we're going to use this technique to cancel out um, reactants until and unless we get our main target reaction up here. So that would give us F2G plus Cl2C, and our enthalpy is gonna remain 30. Is gonna be opposite as well because we're flipping this over the from an endothermic equation, it would become a reaction. It would become an exothermic reaction. So it's going to be negative 38 kilojoules. For the last one, we are going to multiply it with 2. So that would give us 2HClG plus 2F2G plus, sorry, that gives us 2HFG. And as we have multiplied the equation, we are also going to multiply 56.2 multiplied by 2 as well. So that would give us negative 112.4 kilojoule. And now we can cancel this out and see what we have remaining. So like Cl cancels out. HCl cancels out, and henceforth. At the end, we are left with H2 of G plus 2F2G. Yeah, that gives us 2HFG plus F2G. So now we have F2 on both sides. We can just cancel that out and simplify it further. So that would be 2 cancels out, this cancels out. In the end, we are back to our target equation as provided up here. So let's F2, yes, that gives us 2HF. Yes. So we're not gonna forget about the enthalpies over here. We're actually going to add them up, and that would actually give us our main delta H or enthalpy change. So that is going to be negative 184.6 plus negative 38.0 plus negative 112.4. Yeah. And our final answer that comes out of this is going to be negative 335 point 0 kilojoules. So this is our answer. Our final answer would become delta H equals to negative 335.0 kilojoules. So what did we find out? We use these three equations given to us. We manipulated them so we can use them in a simultaneous equation. I think so is what you said in algebra. We cancel out similar stuff on each side, and we are left behind our target reaction, which is going to be Hg plus Fg that gives us 2HF. We are going to, as we're manipulating the equations right here, we are also going to be manipulating the the delta H's. So in the second reaction, we flipped it over. So we flipped positive 38 to negative 38. In reaction 3, we multiply by 2. So we multiply 56.2 with 2. That gives us 12.4. Remaining, we just add all our delta H's together and we get our final answer. So that is how you get the change of enthalpy using Hess's law and using given reactions. Thank you.